Good evening to one and all. In this session, we are going to discuss about the solution procedure for the wave equation, that is one-dimensional wave equation, one-dimensional heat equation, and one-dimensional Laplace equation. Laplace equation, not one-dimensional. Okay. First, we are going to discuss the solution procedure for wave equation by using variable separable method, that is a separation of variables. So this is dou square u by dou t square equal to c square dou square u by dou x square. This is a wave equation. Assume the solution of this wave equation is u equal to x into t. That is u of x comma t equal to x of x into t of t. Our aim is first we have to separate x variable and t variable alone, because u is a function of x and t. Because u is a dependent variable, this dependent variable is depending on two independent variables x and t. We have to convert this two independent variable in the form of x of x. That is, x is a function that is depending on only one independent variable x. Similarly, t is another variable that is depending only on t. So x and t, the combined independent variables can be separated into two different independent variables. Therefore, the general solution u can be assumed to be x of x and t of t. Next, we have to find out x of x and t of t values further, and then the final results can be substituted in equation 2. Then we get the solution u of x comma t for this wave equation. This is the solution procedure. So in this equation, first we have to find out the derivatives with respect to t and x. The derivative means second order derivatives. First differentiate with respect to t, then ut in the left hand side. If you differentiate with respect to t means, then we get ut which is equal to, so x is a constant with respect to t, therefore x into t dash. If you differentiate further, then we get utt. So again x is a constant term because it is a partial derivative, therefore we get t double dash. Similarly, we can find out uxx. At the time, we have to keep t as a constant term, then x double dash into t we get. Substitute utt and uxx value in equation 1, that is in the wave equation. Then the left hand side dou square u by dou t square is utt. Therefore, x t double dash equal to c square is a constant. C square is a constant, positive constant. Then dou square by dou x square is uxx. Then we have to replace uxx value, that is x double dash into t. Separate the variables, x terms in one side and t terms in the another side. Then we get x double dash by x and 1 by c square t double dash by t. Let us equate this these two ratios equal to lambda. This is a random constant, arbitrary constant. So x double dash by x equal to lambda. After cross multiplying, we have x double dash divided by x equal to lambda. After cross multiplying, we have x double dash equal to lambda x. Then take this lambda x into the left hand side itself, then x double dash minus lambda x equal to 0. Similarly, we can take 1 by c square t double dash by t equal to lambda, then we get t double dash equal to c square t lambda, then we get t double dash minus lambda c square t equal to 0. Now we have two equations in x and t, 3 and 4. We have to find out the solution for different values of lambda. Here lambda is any arbitrary constant, then the value of lambda is either equal to 0 or positive or negative. So we have to discuss these three cases in the next coming solution procedure. So let us assume that lambda equal to 0 in the first case. If lambda equal to 0 means then we have x double dash equal to 0 and t double dash equal to 0. After integrating we get if x double dash equal to 0 means if you integrate first time, then we get x dash equal to a constant a1. If you integrating further, then we get x equal to a1x plus a2, because here integration with respect to x. Similarly, if t double dash equal to 0, then we get t equal to a3t plus a4, because here the integration with respect to t. So substituting into equation this that is 2 u x of t u of x of t u of x comma t equal to x of x into t of t, then u of x comma t equal to a1x plus a2 into a3t plus a4. This is the first solution. Next, if lambda is positive, let it be lambda equal to mu square, then we have x double dash plus mu square into lambda we have, mu square into x we have. So m square lambda is positive, therefore x double dash minus mu square, x double dash minus mu square into x equal to 0. If we find the auxiliary equation, then we have m square minus mu square equal to 0, then m equal to mu comma mu. So m equal to plus or minus mu, m equal to plus or minus mu. Then the solution for this is x equal to b1 e power mu x plus b2 e power minus mu x. This is mu x. Similarly, solving the second equation lambda t double dash minus lambda c square into t, we get c mu t plus or minus c mu are the two solutions. Then t can be written as b3 c e power c mu t plus b4 e power minus c mu t. So there are two solutions. Substituting in equation 2, we get u of x comma t equal to x into t. Therefore this type of solution we get. Next, if lambda is negative, then let it be lambda equal to minus mu square. Then we have x double dash plus mu square, instead of minus we have plus, because here minus mu square, so minus into minus plus, so plus mu square into x equal to 0. Then the auxiliary equation is m square plus mu square equal to 0. So m equal to plus or minus I mu. Therefore, the complex roots means the auxiliary equation, that is the complementary function, is c1 cos mu x plus c2 sin mu x. Beta value is here mu. Similarly, for the time differential equation, we have if lambda equal to minus mu square means we get t double dash plus mu square c square t. Then the auxiliary equation is m square plus mu square c square equal to 0. Then we get two roots, that is m equal to plus or minus I mu into c. So after substituting we get c3 cos mu t plus c4 so here one c is missing, so c mu t sin c mu t. Therefore there are three different solutions uh, which is depending on the value of lambda, either lambda equal to 0 or lambda is positive or lambda equal to negative. So equation 5 and equation 6 and equation 7, there are three solutions. These are all possible solutions for the one dimensional wave equation. Okay, for the nature of the problem we can choose any one of the possible solution, that is called a suitable solution. Okay, that value is depending upon the nature of the problem. Okay, next we are going to discuss about the solution procedure for one dimensional heat equation. So heat equation is dou u by dou t equal to k into dou square u by dou x square. So instead of the second derivative in the left hand side, second derivative with respect to t in the left hand side, here we have the first derivative with respect to t. This is the difference between wave and heat equation. So in the wave equation, left hand side is the second order, but here this is the first order. So k into dou square u by dou x square. So first we assume that u of x comma t equal to x of x into t of t. So here one the first derivative alone, so ut equal to x t dash, but in the right hand side uxx, so we have to find out uxx, that is x double dash into t. Then the given equation becomes x t dash equal to k into x double dash into t. Separate the variables x term in one side and the t term in the another side and equate it into an arbitrary constant lambda like the previous case. So we have x double dash minus lambda x equal to 0. So now we have x double dash minus lambda x equal to 0 and t dash minus lambda kt equal to 0. In the first case, let lambda equal to 0, then x double dash equal to 0. After integrating, we have x equal to a1x plus a2 and t is here, t is a first order differential equation. Therefore t after integrating, if t dash equal to 0 means after integrating this equation we have t equal to a constant a3. That's why here we have t equal to a3. Therefore u of x comma t equal to x into t, therefore a1x plus a2 into a3. So this equation a1 x can be written as capital A1x and A2 A3 can be written as capital A2. In the second case, let lambda be positive, say mu square. So the solution, so lambda is positive means we get x double dash. Like in the wave equation, we have x double dash minus mu square into x equal to 0 we have. Therefore, the roots are plus or minus mu. Therefore, the solution is x equal to b1 e power mu x plus b2 e power minus mu x. But in the second equation, we have t dash mu square k into t. Therefore, the auxiliary equation is m minus mu square into k equal to 0. Therefore, it can be written as b3 e power mu square k into t. Therefore, the solution for this is u equal to x into t. Therefore, this is x and this is t. Next, if lambda is negative, then lambda equal to minus mu square, then we get the complex roots. Therefore, the complementary function can be written like this. Similarly, for the 1D, sorry, first order differential equation, we have after integrating we get this solution. After that, the solution for this case is u of x comma t equal to c1 cos mu x plus c2 sin mu x into c3 e power minus mu square kt. So here c3 is missing. c3 e power minus mu square k into t. Therefore, these three equations, so u of x comma t equal to this equation and this equation and this equation, these three are possible solution for one dimensional heat equation. Next, we are going to discuss about the possible solution of two-dimensional Laplace equation. This equation is a Laplace equation dou square u by dou x square. So here also we are going to assume the solutions. Okay, 1 minute. I will share my screen. Okay, next question is the solution procedure for two-dimensional Laplace equation, that is dou square u by dou x square plus dou square u by dou y square equal to 0. So here there is no time variable time as well as time derivative, because here we are assuming the steady state. Therefore, this problem is independent of the time variable. So here x and y, there are two space coordinates are taken into account. So dou square u by dou x square plus dou square u by dou y square equal to 0. Let us assume the solution for this equation is u of x comma y equal to x of x into y of y. Then find out the derivative. U xx equal to x dash into y. U double x is x double dash into y. Similarly, uy is x into y dash. Uyy is x into y double dash. Substitute into the given equation. Therefore, we have x double dash plus y equal to x into y double dash equal to 0. After separating the variables, we have x double dash by x equal to minus y double dash by y equal to lambda, an arbitrary constant. After that, we have x double dash minus lambda x equal to 0. The same solution procedure what we have seen in the wave equation and the heat equation. Similarly, in the second one, y double dash plus lambda y equal to 0. In the first case, if lambda equal to 0, Then x double dash equal to 0. After integrating, we have x equal to a1x plus a2 and y equal to a3y plus a4. For case 2, if lambda equal to mu square, then we have x double dash minus mu square into x equal to 0. So in this case, we have 2, not here. In this case, here we have yes. If lambda equal to mu square means here x double dash minus mu square into x we have. Therefore, here we have lambda equal to m equal to plus or minus mu. But the same positive lambda mu square value in the second equation y double dash plus mu square into y we have, isn't it? Y double dash plus mu square into y equal to 0 we have. In this case we have m values are plus or minus I mu. So for the first case, distinct real root, therefore we can write the solution x equal to b1 e power mu x plus b2 e power minus mu x. But in the second equation, we have two complex roots, therefore the solution can be written as y equal to b3 cos mu y plus b4 sin mu y. Therefore u can be written as u into x into y. Therefore x is this one and y is this one. Similarly for the third case, lambda equal to minus mu square, just to think about this case, if you substitute lambda equal to minus mu squared in the first equation, then x double dash plus lambda into x, plus mu square into x we have. So in this case we get two complex roots. But in the second equation, y double dash minus mu square into y equal to 0. So in the second equation, we have two distinct real roots for the third case. So x in terms of the complex roots CF can be written as, that means the solution can be written as C1 cos mu x plus C2 sin mu x. But for y value, two distinct real roots, therefore the complementary function, that is nothing but the solution y equal to C3 mu y plus C4 e power minus mu y. Therefore u equal to x into y. Therefore these three equations are the possible solutions of two-dimensional Laplace equation. For the nature of the problem, we can choose any one of uh, these three formula, that is fully depending on the nature of the problem. Okay, now we are going to discuss few problems related to heat equation, wave equation and the Laplace equation. So these are all net questions, CSIR net question. So here you can identify this is a wave equation, one-dimensional wave equation, because the time derivative is 2. Second order term, so dou square u by dou t square minus dou square u by dou x square equal to 0. Here the initial condition u of x comma 0 equal to f of x, and the time derivative dou u by dou t with respect to u, the time derivative of the dependent variable dou u by dou t is equal to 0. It satisfies the relation f of x equal to x into 1 minus x. Moreover, f of x plus 1 equal to f of x. Then we have to find out u of 1 by 2 comma pi by 4. There are 4 options. First 1 by 8, 1 by 16, 3 by 16, 5 by 16. We have to find out the solution. How can we find out the solution? So for this wave equation, We have another solution, that is u of x comma t equal to 1 by 2 eta of x plus ct plus eta of x minus ct plus 1 by 2c integral of x minus ct x plus ct into v of s into ds. So here v is ut of x comma 0. So this is called D'Alembert solution. So eta is nothing but u of x comma 0. That is u of x comma 0 is what? F of x. F of x is x into 1 minus x. This x is taken as eta of x. And this dou u by dou t of x comma 0 is v of s. This equation is taken as v of x. Okay, this solution is this first term is called D'Alembert solution. So 1 by 2 eta of x plus ct plus eta of x minus ct. What about eta? Eta is u of x comma 0. So u of x comma 0, in this question they have given x into 1 minus x. We don't bother about v of x, that is it is 0. So this integral term becomes 0. No need to find this one. So if it is a non-zero means, then we have to evaluate this integral also. C value, what about C value? So here the constant term. So in this question C value is 1. Therefore this C becomes 1. So u of x comma t. So in the first term, in this coordinate, first term is x value, second term is t value. So we can substitute the x and t value here, then we get the limit values. Then how can we find the x and t value? It is given in the question itself. U of 1 by 2 comma 5 by 4 we have to find out. Therefore x equal to 1 by 2, t equal to pi by 4. Okay, so here there is no problem because we have x equal to 0. So this integral term becomes 0. It is enough to find out this first term alone. So u of x comma t equal to 1 by 2 f of x plus t, because c equal to 1. So f of x plus t plus f of x minus t, since eta equal to f. So 1 by 2 f of x plus t plus f of x minus t. Okay, now the original question is u of 1 by 2 comma pi by 4. So x plus t means 1 by 2 plus pi by 4. After simplifying this, we have 2 plus 5. Therefore we have 7 by 4. So f of 7 by 4. F of x minus t, then 1 by 2 minus pi by 4. 1 by 2 minus pi by 4. So here minus sign. So 2 minus pi by 4. So minus 3 by 4. Isn't it? So here we have minus 3 by 4. What is f? F is x into 1 minus x. So in this case we have to find out f of 7 by 4 value as well as f of minus 3 by 4 value. So f is x into 1 minus x. So f of x equal to x into 1 minus x. So f of minus 3 by 4 means f of minus 3 by 4 plus 1. Since f of x equal to f of x plus 1, that is given in the question itself, f of x plus 1 equal to f of x. So f of minus 3 by 4 can be written as f of minus 3 by 4 plus 1. Those, therefore 4 into 1 is 4, 4 minus 3 is 1, f of 1 by 4. So instead of f of minus 3 by 4 can be written as f of 1 by 4 with the help of this formula. So f of x equal to x into 1 minus x. So x is 1 by 4 and then 1 minus 1 by 4, that is 3 by 4. So we get 3 by 16. So this value is 3 by 16. Next, we have to find out the value of f of 7 by 4. So f of 7 by 4 means it is f of 1 plus 3 by 4. So f of instead of f of 7 by 4, just we can find out the value of f of 3 by 4. So 3 by 4 into 1 minus 3 by 4. Therefore 3 by 4 into 1 by 4. So we have 3 by 16. So in both cases we have 3 by 4 16 and 3 by 16. So the correct answer is 3 by 16. So u of 1 by 2 comma 1 by 4 is 3 by 16. So this is the answer. So for finding the solution of a wave equation, this is one more solution. This is called D'Alembert solution. Many of you may be aware of this. This is called D'Alembert solution. Okay, now we will discuss the same wave equation, but in the first equation, here the right hand side is 0. Sorry, here the right hand side is 0, but here the right hand side is not equal to 0. This is called a non-homogeneous wave equation. So here u of x comma 0 equal to sin x, ut is 0. So in this case we have to find out the value of u of pi by 2 comma y by 2. Here there is no relation for f of x and f of x equal to f of x plus 1. There is no relation like this. So this is f of x and this is v of x. Let us discuss how can we find out the solution. For the non-homogeneous wave equation, this u of x comma 0 equal to pi of x and the ut is psi of x. In the last problem we have taken this as f and this as b. So here pi and psi. Okay, the solution for this type is u of x comma t equal to 1 by 2 pi of x plus ct plus pi of x minus ct plus 1 by 1 by 2 c integral x minus ct x plus ct psi of s into ds plus 1 by 2 c. So this term is especially dedicated to the right hand side function. So 1 by 2 c integral 0 to t integral x minus c into t minus s. The upper limit is x plus c into t minus s. So here double integration, first integral with respect to x and the second integral with respect to t. So now the variable can be changed as y and s. Let us see how can we solve this problem. So here this is h of y comma s. We have to find out the value of u of pi by 2 comma pi by 2. Substitute into this formula. Therefore we have 1 by 2 pi value. Pi value in the question they have given sin x. So this is sin x, this is 0. Therefore this integral becomes 0. No need to find this. This is tends to 0. No need to find out this because ut term is 0. But here psi is sin x. Sorry, pi is sin x. Pi of x is sin x. but psi of x is 0. So the second integral becomes 0. So instead of this pi of x plus ct, c value is 1. Okay, so pi of x plus t plus pi of x minus t. So what will we get? X value is pi by 2, t value is pi by 2. So it is also easily we can write down. So in the first term, sine of pi by 2 plus pi by 2 plus sine of pi by 2 minus pi by 2. So this is 2 pi by 2, therefore pi. Sine pi by 2 minus pi by 2, 0, thus, therefore this is also 0. Sine of pi value is also 0, therefore this term becomes 0. Second term is also 0. So it is enough to evaluate the last term alone. So 1 by 2 integral 0 to t value pi by 2. So here c equal to 1. Okay. Let us discuss how can we find out this value. Here c value is 1. Next, x value. X value is pi by 2. So x minus pi by 2 minus s. Then x value is also pi by 2. Then pi by 2 minus pi by 2, minus of minus plus. Then we get pi by 2 get cancelled, therefore lower limit becomes s. Similarly, in the upper limit, pi by 2 plus pi by 2 minus s. So pi by 2 plus pi by 2 becomes pi minus s. So the upper limit becomes pi minus s. And h of y comma s. So h of x comma t e power x minus 60, replace x by y and s by t, sorry, t by s, then e power minus e power y minus 6s. So integrate with respect to y, we have e power minus e power y So take this minus sign as a common term, then minus 1 by 2 we have integral 0 to pi by 2. If you integrate e power y, again we have e power y. Next, after integrating 6s with respect to y, we have 6sy. Okay, you have to carefully integrate with respect to which variable we have to integrate first. So e power y plus, so now we are integrating with respect to y. So here there is no y term, so 6s is a constant, therefore after integrating dy we have y. The limit value is s to pi minus s into ds. One more integral we have to evaluate. So minus 1 by 2, after substituting the upper limit we have e power e power pi minus s plus 6s into pi minus s minus, after substituting the lower limit we have e power s plus 6s square. So minus 1 by 2 e power pi minus s by minus 1. Now we are integrating with respect to s, therefore pi is a constant. If you differentiate minus s, we have minus 1. Next, after integrating e power s, we have same e power s. Next, in the second term, 6s into pi minus s. After simplifying this, we have 6s pi minus 6s square. So here also we have minus 6x square, therefore 12s square we have. So after integrating this 6s pi, we have 6 pi as a constant term. If you integrate s, we get s square by 2 minus 12 s square s cube by 3. Limit is 0 to pi by 2. So here pi minus s value is pi by 2. So pi minus pi by 2, we have minus e power pi by 2 minus e power pi by 2 plus, if you cancel this term, we have 3. So 3 pi square, 3 pi square by 4 minus 12 3. then the value becomes 4. S cube means pi cube by 8. After simplifying, we have 2, this is a 4. So e power here minus e power pi by 2 minus e power pi by 2. Therefore, minus 2 e power pi by 2. After substituting the lower limit, we have this term. This is 0. So minus e power pi, e power 0. Therefore, minus 1. These two terms are 0. Next, here minus 2 e power pi by 2. Here we have 3 pi cube by 4. Here minus 2 pi cube by 4. So we have 1 pi cube by 4. Minus into minus plus e power 5 minus into minus plus 1. So after multiplying minus 1 by 2 we have, so minus 1 minus 2 becomes plus 1, so e power pi by 2. Then here we have minus pi cube by 8. Here also e power pi by e power pi by 2 minus 1 by 2. So e power pi by 2. Then the remaining, the first and the third term, if you take e power pi by 2, this term becomes 1. But in this term, remaining one e power pi by 2 term is there. Therefore, 1 by 2 e power pi by 2 minus pi cube plus 4 by 8. So, this is the answer. So, if we check the solution, the answer is, so you have to carefully choose the correct answer, because there are many answers related to the same correct answer. So you have to carefully select the correct answer. So e power pi by 2, e power pi by 2, 1 minus 1 by 2. So e power pi by 2, 1 minus 1 by 2 e power pi by 2 minus pi cube plus 4 by 8. Okay, this is the correct answer. So the same wave equation, but it can be solved with the help of D'Alembert solution. Okay. Okay. Next question is heat equation. For the heat equation, we have u of x comma 0 equal to 1, and k value is here 1. We have to find out the value of limit t tends to 0 plus u of 1 comma t. So here we have one formula like wave equation, that is this formula. U of x comma t equal to 1 by square root of 4 pi t integral minus infinity to plus infinity e power minus, okay, this term. So here we have to evaluate this integral. So 1 by square root of 4 pi t integral minus infinity to 0 integral minus infinity to 0 e power minus x minus y the whole square by 4t into f of y. This f of y value is, here we are considering only 0 to 1. Okay, so 0 to 1 only the value exists, and u of x comma 0 equal to 0 for the remaining interval. So 0 to 1 only the function value is 1. For the remaining values the function value becomes 0. So this minus infinity to 0 the value is 0. Similarly 1 to infinity the value is 0. So these two integrals become 0. So it is enough to evaluate the second integral. So integral 0 to 1 e power minus of x minus y the whole square by 4t into dy. Here we have to find out u of 1 comma t. Therefore x value is 1. Substitute that also. So u of 1 comma t, therefore 1 by square root of 4 pi t integral 0 to 1 e power minus, instead of x we put 1 minus y the whole square by 4t into dy. Now we are going to integrate by substitution method. So let 1 minus y by square root of 4t equal to z. So minus dy equal to square root of 4t into dz. Next we have to check the limit value also. If y equal to 0, then we have z equal to 1 by square root of 4t. If y equal to 1, then z equal to 0. Then 0 to 1 becomes 1 by square root of 4t to 0. So lower limit is 1 by square root of 4t, upper limit is 0. So this becomes e power minus the full term is z, therefore here we have to square, therefore e power minus z square. Next dy is minus square root of 4t into dz, therefore minus square root of 4t into dz. Limit value 1 by square root of 4t to 0. So square root of 4t is a constant, so we can take outside from the integral. So if we change the limits, then we get one minus sign, that minus and this minus becomes plus 1. So after integrating e power minus z square, we have the formula e power minus z square is simply root pi, that is 1 by 2. The value becomes 1 by 2. So after simplifying this, we have root pi, but the limit should be 0 to infinity for by using this gamma function. So here the limit is infinity, because t tends to 0 plus. T tends to 0 means 1 by 0 infinity. Therefore this value becomes root pi. So root pi, yes, here also one substitution is there, therefore we have 1 by 2. So 1 by 2 into this value becomes root pi. So root pi get cancelled. So in the final we have 1 by 2. Therefore the answer is 1 by 2. So this is the answer. So for this you have to memorize this formula. If you know this formula, then you can attempt the question. Otherwise you can't. Okay. Next one, linear PDE x into dou u by dou x plus y into u dou u by dou y equal to minus xy. Here u equal to 5 and xy equal to 1. So we have to find out the solution. There are 4 options. So this is a Lagrange's PDE, because here P small p plus q small q equal to r formate. So we have to write down the auxiliary equation, that is dx by x equal to dy by dx by capital P equal to dy by capital Q equal to dz by capital R. Therefore the Lagrangian multipliers in the first case, we can select y, x and u. So in this case y, here x, here u. Then what will happen? If you multiply both the numerator and the denominator by y in the first ratio, and both the numerator and the denominator by x in the second ratio, similarly by u in the third ratio. So y dx plus x dy plus u du divided by, we have xy plus xyu minus xyu. These two terms get cancelled, remaining xy we have. So for eliminating this xy also, we are equating this by the third one, that is du by minus xy. Then this xy and xy get cancelled. So remaining we have y dx plus x dy plus u du equal to minus integral du. So this is the formula for xy. So if you differentiate xy, we have y dx plus x dy, therefore integration of this is xy. After integrating u, we have u square by 2. After integrating this, we have minus u plus integrating constant c. They have given the question itself u equal to 5 and xy equal to 1. So substitute xy equal to 1 and u equal to 5. So 25 by 2 equal to c. Therefore, the integrating constant is 37 by 2. Substitute into this equation, then this equation now becomes xy plus u square by 2 equal to 37 by 2. So write in terms of u. So here add and subtract by 1. So u square, take LCM, then this term becomes 2u. Add and subtract by 1 because then only it is becoming a perfect square. Therefore, we can write u plus 1 the whole square. So in the remaining term, after taking LCM, we have 2xy. This 2 get cancelled. After taking LCM, we can cancel this 2. So we have 2xy minus 1. So these two terms, these three terms can be combined as u plus 1 the whole square plus 2xy minus 1 minus 37 equal to 0. So u plus 1 whole square equal to 38 minus 2xy. So u plus 1 equal to plus or minus square root of 38 minus 2xy. So u equal to plus or minus square root of 38 minus 2xy minus 1. So now we are getting this, this is a solution. So here u of x comma y exists when xy less than or equal to 19 and u of x comma y equal to u of y comma x when x is greater than 0, y is greater than 0. But the second is the same result, but here instead of less than or equal to, here we have greater than or equal to. So let us check. So here if xy equal to 19, then what will we get? Then 38. Therefore 38 minus 38 0. Then u equal to minus 1. Suppose xy is greater than 19 means what will happen? Then this term becomes negative. Then square root of negative term becomes a complex one. But here we are assuming only the real values because here we are considering only real terms. X is greater than 0, y is greater than 0 like that. Therefore, if we take xy is greater than or equal to 19, then this term becomes negative and complex terms will exist. Therefore, option 1 is correct because xy less than or equal to 19 is correct. Next, we have to, therefore, if option 1 is correct means 2 is wrong. Okay, next we have to check either whether 3 or 4, whether 3 is correct or 4 is correct. Okay, we are going to check all the 4. U of 1 comma 11, this value is 3, and u of 13 comma minus 1 7. So u of 1 comma 11 is 3 and u of 13 comma minus 1 is 7. U of 11 comma 1 means value minus 5. U of 1 comma minus 1 means value minus 9. Therefore 3 comma 7, but here minus 5 comma 3 we have, therefore this is wrong. Therefore this is correct. 3 comma 7 is correct because here minus 5 minus 9 we have, but in the fourth option we have 5 and minus 5. Therefore this one is wrong. This is the correct. Option 3 is correct. Option 4 is wrong. Therefore the correct answer is 1 and 3. Similarly, we are going to discuss about the solution procedure of wave equation with the help of a D-element solution. So here f of x equal to sin x, and there is no, sorry, here both terms are exist. So this is pi and this is g, and the c value is 1. So u of x comma t equal to 1 by 2 pi of x plus t plus pi of x minus t 1 by 2 integral x minus t x plus t g of s into ds. So u is x cube and ut is a sine. Substitute 1 by 1 in this D-element solution. So u of x comma t equal to 1 by 2 pi of x plus t Here pi of x plus t is x plus t the whole cube, because x cube is the value of pi. So pi of x plus t means x plus t whole cube. Here x minus t whole cube plus 1 by 2 integral x minus t to x plus t, g of s, g value is sin x, so sin s into ds. We have to find out the value of u of pi comma pi. So x value is pi, t value is pi. So pi plus pi, 2 pi the whole cube plus pi minus pi 0 plus 1 by 2 minus cos, after integrating sinus we have a minus cos s integral 0 to 2 pi. So this becomes 8 pi cube plus 1 by 2 minus cos s, the value of, after substituting the limit value, cos 2 pi value plus cos 0 value. Cos 2 pi is 1. Here one minus sign is there, therefore minus 1. Cos 0 value is 1, therefore plus 1. So minus 1 plus 1 0. So here 8 pi cube by 2, therefore 4 pi cube. Therefore the answer is pi cube 0 4. These are all wrong. The correct option is 4 pi cube. Next we are going to discuss the Lagrange's equation. In the question itself they have mentioned Lagrange. Therefore we can find out the solution with the help of the auxiliary equation. So here capital P x square, capital Q y square, R is x plus y into z. We have to find out the solution. So here we are going to take the first two ratios. So after integrating we have minus 1 by x equal to minus 1 by y, minus 1 by c is an integrating constant. Minus equal to c1. This is integrating constant. So here minus c1, this is integrating constant. So if you take this 1 by x into this side, so we have 1 by x minus 1 by y. After taking this minus c1 into the left hand side, so we have c1. Next, subtracting the first two ratios and equate it with the third one. So dx minus dy by x square minus y square equal to dz by x plus y into z. So x square minus y square can be written as x plus y into x minus y. X plus y get cancelled, the remaining term is dx minus y by x minus y dz by z. After integrating we have log of x minus y equal to log z, the integrating constant c2. So we have x minus y by z equal to c2 after taking the exponential. So this is the first solution u, this is the second solution v. So the general solution can be written as pi of u comma v equal to 0. This is one form, and the second form is u equal to pi of v, and the third form is v equal to pi of u. In any form we can write. So f of x minus y by z 1 by x minus 1 by equal to 0. This is the one type of solution. So here f of x minus y by z 1 by x minus 1 by equal to 0. This is the correct solution. But this solution can be written as, so option 2 is correct. Option 1 is f of xy by z 1 by x minus 1 by y equal to 0. This is option 1. So for this we are going to collect the another ratios. In the first ratio we have dx by x square. Second ratio dy by y square. Then divide the first ratio by x, then we have dx by x. Similarly, do the same thing in the denominator also. So we have x square by x, so we have only 1x. Similarly, in the second ratio, so dy by y square by y. Therefore, we have dx by x divided by x, dy by y divided by y. Adding those two, we have dy by x plus dy by y divided by x plus y, equating this with the third one. So we have dz by x plus y into z. X plus x y in the left hand side and the right hand side get cancelled. So we have dx by x plus dy by y equal to dz by z. After integrating, we have log x plus log y equal to log z plus integrating constant log C3 C. So this can be written as log xy. If you take this log z in the left hand side, we have log xy by z. After taking exponential term, we have xy by z equal to C3. Either we can say that xy by z equal to C3 or z by xy equal to C4. There is no problem because 1 by C3 can be written as C4. So option 1, f of xy by z comma 1 by x minus 1 by y equal to 0. It is also a correct option. Then the fourth option, z by xy equal to f of 1 by x minus 1 by y. It is also a correct answer. Therefore, there are three solutions. The only wrong answer is this one. Next, this is an example for the classification. So here, this is a second order PDE, 8 zxx minus 2 zxy minus 3 zyy. We have to find out the classification. So here, there are 4 options. In the first two, this is the type of PDE. In the second, third and fourth, we have the solution of the PDE. So first we have to find the solution of this second order PDE. In the last session, we have discussed the solution procedure of second order homogeneous PDE. This is a simple equation because right hand side is 0. Therefore, there is no need to find out the particular integral. It is enough to find out the CF alone because CF itself is a solution. So the auxiliary equation is 8m square minus 2m minus 3. After finding the roots, we have m equal to 3 by 4, m equal to minus 1 by 2. Therefore, z is f of y minus x by 2 plus g of y plus 3x by 4. So, y minus x by 2, y minus x by 2. So, y plus x by 2, this option is wrong. So, y minus x by 2, y plus 3x by 4, this option is correct. Next, classification. So, b square, b value is here 2, sorry, minus 2. Upon minus 2, the whole square is 4, minus 4 AC, a value is 8, c value is minus 3. Therefore, 4, 8, 3, therefore, we have 96. So, this is a greater value, positive value. Therefore, the given PDE is hyperbolic. So, given PDE is elliptic is a wrong answer. So, in the a single question, we have to solve the question as well as we have to find out the discriminant value also. Here a simple question, x into dou square u by dou x square plus y into dou square u by dou y square equal to 0. Here a value is x, b value is 0, c value is y. So, b square minus 4ac is minus 4 into xy. So, we have to carefully select the answer. See, here one minus sign is there. Okay. If already this value is negative. So, in the first option, x is greater than 0, then x is positive value and y is negative value. If x positive, y negative means xy is negative. This is negative, this is negative. So, negative into negative becomes positive. Therefore, b square minus 4ac is positive. Therefore, we get hyperbolic. So, the first option is correct as of now. Let us discuss the second option. If x is greater than 0 means x is greater than 0 and y is less than 0, then xy becomes negative. Xy negative, and after multiplying this negative value minus into minus plus, then we get hyperbolic only, not elliptic, therefore this is wrong. Let us discuss the third option. Here x is positive, y is positive, then xy must be positive. After multiplying this with the negative value, we get only negative value. So the hyperbolic is not positive. The hyperbolic is not possible. Next, let us discuss the fourth option. X is less than 0, y is greater than 0. Then the product must be negative. The product negative and multiply with minus 4, then it should be positive. So positive means we get hyperbolic only, not elliptic. Therefore, this option is also wrong. So the correct option is hyperbolic. So the question is simple. We can easily find out the discriminant value. But while selecting the options, we have to concentrate more. Okay. So this is the last question. So here we have one wave equation, and x belongs to 0 to 2 pi. Here this is a simple question. No need to find anything. Here no, there is no D'Alembert solution. No need to find anything. Just substitute u of x comma 0 equal to u of x comma 0 equal to e power isx. So in the first option, okay, let us discuss the fourth option. If u of x comma t equal to t plus x square by 2, substitute t equal to 0, what will happen? X square by 2. So u of x comma 0, in this by this option we have x square by 2, but the original value is e power isx. Therefore, we can say that fourth option is wrong. Okay, next we will discuss first option. So in the first option, substitute t equal to 0, then this term becomes 0. So this term becomes 0 means e power 0 is 1. So we have e power isx, e power isx. So u of x comma 0 equal to e power isx. Moreover, if you differentiate uxx and utt, it satisfies the wave equation utt equal to uxx. So you have to check these two conditions for all the options. So these two are satisfied by 1. Therefore, the first option is correct. Similarly, you can check for the second and the third option also. These two are also these two satisfy the two conditions. Therefore, the correct answer is 1, 2, 3. So the wrong answer is only 4. Okay. So try yourself. I hope now you have a little bit knowledge about the partial differential equations after listening my classes. So it is a vast area. PD is one of the complicated subject in mathematics. So I try my level best. You can understand a little bit what are the solving procedure of partial differential equations. All the best for all the aspirants. Uh, I wish all the participants to clear the set exam. Thank you.
Thank you, ma'am.
Thank you so much, ma'am.
Am I audible, ma'am? Ma'am? Am I audible, ma'am? Ma'am?